Hello and welcome to another Java tutorial. In this tutorial, I'm going to look at the item 2 of effective Java, which is all about builders. So if you've been doing Java programming for a while, you've definitely come across builders and builder design patterns, which are very important in Java programming and in general in any object-oriented programming. The concept of builders is very important. So item 2 says that consider a builder when faced with many constructor parameters. Now, why is it that this item suggests builders? So when object has many parameters that need to be initialized, so note that initialization also a key. And we know that by default, if you have some member fields in your class Java, JVM will initialize them with default values if you don't initialize them. And then, however, most of the time this initialization means we want the user to specify values at the time of the constructing the object, right? Now, if obviously we know that the very first thing to do is to provide a constructor. The problem is that constructors, if we want a user to set like 10 fields, then constructor would take 10 items, and we already know that, I mean, the name of the parameters of the constructor or any method in Java doesn't matter, right? In the class file, when JavaC compiles your Java code, the name of the parameters are erased, right? There is no mention of the name of the parameters, only the type. So if you provide a constructor with 10 arguments, let's say all of them are int or double, then really the user doesn't have any idea what these parameters are unless you provide a very good documentation, right? So that's why we go for builder. And remember that in the first item of the effective Java, it was all about the factory methods, but sometimes the factory methods are not good enough, right? Again, factory methods, they still deal with asking the user for some parameters, and all the parameters must be given to the factory method in one step, right? However, the nice thing about builders and the whole idea behind builders is that you can provide parameters to the builder step by step. And the other thing is that because now we're dealing with a separate object, a builder object, the builder object can have a state. So at each point that the user provides one parameter, for example, the state of the builder can change. So it provides much more flexibility in terms of how the object is constructed. However, obviously you see the problem here. The main problem or the main downside of using builders is that in order to create an object, you have to create a builder object first. So it's like the memory consumption is higher, obviously. So a builder for type T could be any object type, provides a build method, which typically doesn't have any parameters, doesn't take any parameters, and eventually returns a object of type T. And in more advanced cases, it can also return a subtype of T. And we will briefly discuss the inheritance in the builder chains. So if you have a type T and then you have a subtype of T, you can create a builder or provide a builder for T and also inherit from that builder and provide another builder that provides a subtype of T, right? Eventually, any builder type, the convention or the contract of the builder is that to provide a build method that doesn't take any parameters and return your object. Naming convention for the builders is that the object name plus builder. And the very famous example is a string builder in JDK in the Java API itself. And here's a snapshot of some of the public methods in the string builder class. So we want to build a strings step by step, right? And therefore we create a class, a string builder. So we have a class that has the name of the object type plus the builder. So a string builder returns a string object when you call the toString method, for example, on it. So main property of the builders is that typically they have fluent interface, and that's also very important because Java allows method chaining. And if you take advantage of that by returning a reference or a pointer to the object each time a method is called on the builder, then you can chain all these method calls. And sometimes it becomes very convenient to do so, right? So each method call returns a reference to the builder itself. And if you look at these public APIs for append, for example, in the string builder, you see that the return type is a type string builder. And if you look at the code, the implementation, you see that all these methods return a this. This means reference to the current object, right? And that's how you can fluently chain all different methods, all these append methods. So method chaining, no need to break into several lines, and that's very nice thing to do. And the example, obviously, as I mentioned, a string builder is the most famous builder example, and a string builder provides a fluent builder, right? So each method call, each append call returns a reference to the object, to the string builder itself, right? And for the string builder, I believe you don't need to call the build method. You can call the toString method, because if it's building a string and the contract of the toString method is to always return a string, then instead of using the build, we can use the toString, right? All right, so let's see what the book has to say about item 2. So static factories and constructors share a limitation, and as I mentioned, that's because they do not really scale well to large numbers of optional parameters. And sometimes when you want to provide a parameter value for parameter, it affects the state or basically the values of other parameters, right? So so you kind of need some sort of object of type builder that changes its state as it gets the parameters step by step, right? Builders are classes, objects that in fact can have a state, right? So traditionally, programmers have used the telescoping constructor pattern, which means if you eventually have like 10 optional parameters for constructing your class, you can provide a constructor that takes all the 10, and then you can provide a constructor that takes 9 parameters, and then in the object itself you call the this method, right? This with parentheses, and basically you refer to other constructors and then provide default values for some of the parameters. This is called the telescoping constructor pattern. You can Google it to understand what it exactly is, but simply saying is that it's just referring to other constructors, and then when you refer to those, you set some default values for some of the parameters that are not specified in that particular constructor call. So telescoping constructor pattern, in which you provide a constructor with only the required parameters, another with a single optional parameter, a third with 2 optional parameters, and so on, culminating in a constructor with all the optional parameters. Now Java, unlike Python, it doesn't allow default values or keyword arguments. C++ allows default values, so you probably don't end up doing this kind of telescoping constructor patterning, but Java doesn't allow default values for the parameters of a method call or a constructor call, so you kind of end up doing this. A second alternative when you're faced with many optional parameters in a constructor is Java beans pattern, and this means you provide a default no argument constructor or a parameterless constructor, and then you provide lots of setters in order to for the user or the client who uses your API to basically set the values of the parameters or initialize them step by step. So Java beans, it just means you call a parameterless constructor. This is the default constructor. That's one of the main contracts of Java beans. It has to have a default no argument constructor to create the object, and then call setter methods to set each required parameter and each optional parameter. And the contract is that the name of the setter is set, and then the name of the parameter. So if you have a point class that has 2 fields, x and y, you have to have set x and set y. These are the contracts of a Java beans, right? And if you're familiar with the records, the concept of records that were introduced at some point in JDK, right now we are at JDK 17 and the records are finalized and part of the standard language features. You know that records don't follow the Java beans patterns. So if you declare a record point with 2 fields x and y, the getters are basically x and y. They're not get x and get y. So records don't follow the patterns of Java beans. But the contract of a Java bean is to have a default no argument constructor, and setters and getters with the contract is set get plus the name of the field. A disadvantage is that Java beans pattern precludes the possibility of making a class immutable, because you have to have these setters, right? And setters signify or basically indicate to the client of the code or the user who's using your API that, hey, you are actually mutating the state of this object, right? And so you, and the other thing is that if you're mutating the state after creating the object, you cannot declare the fields in your class final, right? Because if they're final, if the fields are final, they have to be initialized when a constructor is called, and after that you cannot change the value of those fields, right? So you cannot really have setters that change the value of a final field. That's another thing. So with setters and all the Java Beans pattern, it's not easy to declare your class immutable, and it requires added effort on the part of the programmer or the person who develops the API to ensure thread safety, right? And again, the idea here is that if your class is not immutable, then if you're working in a multi-threaded environment, then there might be some race conditions. A thread might call the setter method, and another thread might also call the setter method, and it's not clear what the state of the object is going to be in between those calls. Or a thread might call a setter and set the value. At the same time, another thread might call the getter, and get tries to read that value, and then the question is what happens there. Obviously, Java provides some ways of controlling this behavior. The most inefficient way is synchronizing those setter getter methods, which basically defeats the purpose of multi-threading, because then a thread gains access to the global lock of the object, and other threads are starving to access to that object. That's not a good way. The other way is synchronize blocks instead of synchronizing the entire object. The other way, obviously the more efficient way in dealing with setters and getters in a multi-threaded way, is probably just declaring the fields volatile, which means JVM ensures that they will all the threads always see the same values, right? It has some performance hit, but the performance hit is probably less than declaring the methods, the setters and getters synchronized, right? So let's head to Eclipse and try to quickly look at the builder. So inside Eclipse, I'm going to create a new package, item 2 of the effective Java. In item 1, we had this point, right? So let's create that one more time. So we have this point class, and we want to provide an API so for the user to be able to construct this. So we have double X, double Y, and then we don't want to provide a constructor, or maybe let's we can declare the constructor private, right? Point double X double Y, and then this dot X is X, and this dot Y is Y. And we said that this is for Cartesian coordinates. If we want to build a point for Cartesian coordinates, so Cartesian coordinates, and then we said that we can provide another constructor, again private, for basically polar coordinates. And we saw that because the type of the parameters is the same, we cannot really basically provide just double for the Cartesian. So we have to either provide a dummy or basically do some other way. So here I'm going to just provide a dummy. Note that the user doesn't have access to this API, so it's for my own use, right? And then int dummy. Or we can set the units here. That's another thing. So maybe I can create a enum which holds the units of the angles that we provide in the polar. Here I'm just going to provide a string unit, and this string can be like a degree or rad, right? Something like that. So we're going to get the, so we're going to say that if unit equals basically degree, then our the unit is specified in degree. Else we're going to assume that it's just rad. So, and then we're going to do something. So let's declare a phi1 for example here, and then phi1 is phi times 100 math.pi. We have to convert it to rad, so math.pi divided by 180, and otherwise or I can just say fee underscore fee rad, which means this fee is always in red, and here this just becomes dot fee, right? And then now we store the xy in the Cartesian anyway, so rho times math dot cosine of phi rad, and y is rho dot math dot sine, right? So again, the user doesn't have any access to this. Let's also quickly override the toString method. All right, let's accept the default. And then what we're going to do, okay, we don't allow the user to access these constructors, but then we provide a builder, right? Class, we call it PointBuilder. And the contract of this is that eventually we have to have the build method. This is the convention, and it's always best to follow this convention. So follow this convention, follow this convention. Again, the convention, the first rule is that whatever the name of the class is, the builder should be the name of the class plus builder. The second convention is that you have to have a public method that returns your object type, and it should be named build, and it doesn't take any parameters, right? So what are we going to do? We can also say double x and y, and then we're going to allow the public point builder. Basically we're going to allow no arg parameters, and then we're going to provide a few things, right? We're going to say public point builder. We're going to provide our fluent interface for the builder, fluent interface, and then we're going to say that x double x, and this dot x is x, and return this. So this line is what makes it possible for fluent interface. Return a reference to current builder object, right? So we set the x. We can call it x or set x. Usually with builder we don't use setter patterns, we just say the name of the parameters, right? So x and y, this dot y, and then y, and then here we're going to say that return new point x and y. Now alternatively what we can do is the constructor of the point at the moment is private, so so this class, which is separate, is not accessible. So what we can do, we can make it package level access, right? So if you look at the contract of the constructor now, it's a triangle, which means it's a package level access, right? And it's a field triangle, which means it's a method. The ones that have a white dot, it means these are fields, these are not method. But a triangle, a blue triangle, means it's a package level access, because eventually the users or the clients are going to get our binaries, and our point and point builder both are in the same package. So the users still don't have access to the constructor of the point, because the access is limited to whatever class is inside this package. And then this builder can call it. Now obviously if there are other packages and those classes need to call the constructor directly, then this might cause problem. But again, using the pointer here, it's better idea. So let's create a test class here that has a main method, and let's create a point. So var p1 is we're going to create new point builder, all right? And then we're going to call now let's make these fields private, right? So and then we're going to say x is 2.1, and then y is 3.5, and then we're going to build it. So this is a typical method chaining you see, and it's very expressive, right? So that's one of the good things about the builder pattern. It's very expressive, and again, as long as you stay with this contract that the name of the field or the method calls in the builder is the name of the fields in your class. Like PointBuilder has a method x that sets the x value of the field here, right? Then it's very expressive what's happening, and eventually you have to call the build method, and the construct this knows that it has to be a point, or we can explicitly mention it as a point, and then we do a sysout on p1, right? So let's see if this works. Yes, now we have 2.1 and 3.5. Now obviously we can have basically right now we provided x and y, and now we can also provide a for the Cartesian we can provide rho and phi rod, right? Okay, or we can also provide another method phi, but that's for phi degree, right? So this is another way. So now if somebody calls phi, they already know what they're calling. Is it the rod or degree? And then we can call the appropriate builder. Now the problem here is that somebody can call x and also rho. So right now we're providing simultaneous access to these, and this is probably not a good idea. So there are ways to change this approach. So limit the access. So if somebody chooses a Cartesian, we can provide only these two methods. And if somebody calls if somebody wants to create have a builder that only provides these two methods, rho and phi, or maybe these three, then it's possible. And we'll talk about this as we progress in our talk or lectures about builders. So the question is, how do we limit the access to x and y for building the Cartesian points, or accessing rho, phi rad, phi degree to limit the basically the polar point. So one way is to use a static nested class or a static inner classes, right? So we can say public static, and we make these classes public, Cartesian, right? Cartesian, and then we remove these basically into the Cartesian class, right? So what happens here is that let me just comment these out. Now right now let's see, public static Cartesian. So right now we don't have access to these fields, right? So what we can do is when somebody creates the PointBuilder, and so because these are static inner classes can be directly in each constructors, can be directly accessed, right? So you can just say new PointBuilder dot Cartesian, right? So this is one way. So you can have access to this inner class and then directly call the constructor. So we can say public, and we can provide the constructor. So we can say Cartesian double x double y. All right, and then let's comment this out for now. So we have to also add the class here. And then here, now we can move these x and y into this Cartesian class, right? And then this dot x, and again, if we want to make this builder, so we don't specify, we provide a new R constructor, and then our fluent interface now basically we can return a reference to the Cartesian itself, right? Okay, now everything works fine, and then so these are private, but we're setting them, and eventually we call the build method inside the inner class, the static inner class, right? And then because this is a Cartesian build, we build this right inside. We already know that we have to call the constructor that takes the basically the x and y, the Cartesian points, right? So again, now we can do exactly the same thing, but for the polar. So instead of saying Cartesian, we say polar, and then in the polar, so we return, again, we make each nested inner class a fluent interface, and now we set this to basically row, and here we can just save the row and phi we always only save it as rad, right? So in radians, okay. And then phi, but we can also provide phi rad and phi rad, this phi rad, and then in the build we return one that takes row and phi, and then with the unit was rad, right? We only set it to rad. And then however, we can also provide another builder method for degree, right? Phi degree, and we just initialize phi rad with phi degree times math.pi divided by 180. All right. So again, now we are restricting the access to the Fluent API of the point builder through the static inner classes. So each static inner class is still Fluent for its own type, right? And then both of them also provide build, so the user, it knows that eventually it has to call build. So let's go and try this. So this was our initial way of dealing with the builder. Now let's say var p2 is new point builder, right? But then we have to call either Cartesian or polar. So we call Cartesian. There is a no arg constructor, and now the only methods that are available to the user are x and y. There is no row and phi, right? That's because the Cartesian inner class already limits the access of the API to x and y. That's how we limit. So the user makes a choice, and only the methods of the builder that adhere to that choice are available. So we only have x 2.1 and y 3.5, and we still have the build method. So each static nested inner class has it. So sysout p2, and as you can see, this should work fine too. Yes. Now we can also work with polar. So new point builder dot polar, right? And now we can the only methods that are available to us are row, phi rad, and phi degree. There is no method x and y because the polar builder inside the, or basically the polar interface inside the point builder doesn't allow or doesn't have x and y. So we just say phi or start with row 1.5, and then phi degree and rad, let's say 30 degrees. And again, it also provides the build, so the user actually doesn't feel whether it's using. Eventually, the user knows that it's using some sort of builder and has to call the build. And sysout p3. All right. So this is another way of building the points. So that's the use of a static inner class inside the pointer inside the builder to limit the access to the API, right? The type of method calls that the user needs to build the object. However, it's more convenient and more popular to put the pointer builder right inside the class. So instead of having a point builder here, I can create a static class inside and call it the builder. So inside the point itself, I can create a class. So public static class builder. All right, and then or we can also basically copy and paste these right inside the point class. So we put the builders right inside the class itself, right? And now we can say that var p4 is new point dot Cartesian, and then x 2.3 and y 3.5, and then build. So that's another way. Or we can call these instead of Cartesian, we can call this Cartesian builder or something of that sort. Or we can nest Cartesian, or we can also nest these inside another class, right? So public static class point builder, and we can nest all these two. All right, so now we have the builder class that encapsulates the Cartesian builder and polar builder. And then here we say point new point dot builder, get a builder for the point, and dot Cartesian. So the builder provides two separate APIs, and then x 2.3 and y 3.5, and then build. So there are all these kinds of way that you can implement the builder. Another way is through a hierarchy. So you can have a hierarchy of point, a Cartesian point, and a polar point that inherit from the point. And then you can have a point builder, a Cartesian point builder that inherits from the point builder itself, and also a polar point builder that inherits from the point builder, right? However, I mean, it's more customary to put the builder right inside the class itself, and you say when you want to use it, you say new the type dot the builder, and then you can start using the builder, and you already know that at the end you have to call the build itself. And again, if you want to really restrict the API that user has to use based on the type of choices that are available, you can have nested static inner classes inside the builder class, so that those limit the interface or the method calls that the user has access to. And inside any of them, you also have to have the build, so so you can the user eventually can call the build. One thing that I mentioned is that builders have a state, right? So this builder can have a state, or any of these Cartesian or polar, they have a state, right? We are saving the state, and when the user calls the build, we use the internal state of the builder to eventually build the object. Now let's say because of this, we have control in between the method calls x and y to control some aspects of. So basically we can add additional checks. For example, let's say I want to limit the points that the user can build with the Cartesian to only first quadrant and fourth quadrant. So first quadrant, I know that x is positive and y is positive, and then fourth quadrant is x is positive and y is positive, right? Y is negative. So the limitation or the constraint here is that the x coordinate must always be positive, right? So if somebody calls the y, I accept it. If somebody calls the x, I can provide an additional check. So instead of directly assigning that, I can say this dot x equals x if so we check the condition. We check the condition. If x is greater than 0, we assign x. Otherwise, we assign minus x, right? So the condition goes here. So this is the ternary operator, and then this is independent of y. But we might have more complicated constraints. So for example, let's say I want to make sure that x is always greater than y. This is my constraint. So if you provide a constructor for the point that takes x and y, then the user really doesn't know, or there is a case that if we just provide this constructor, then this just takes the values and assigns them. But now here, if somebody calls the y, we accept it. If somebody calls the x with some value, we can check that basically based on the current value of y, what happens. Or let's say we want something to, we want the point to always be on the x equals y curve. So if somebody sets the x, we make sure that the y is also on this line. If somebody calls the y, we make sure that x is also on this line. So if I run this again, and as you can see, the first point, the first builder provides a points that is always x and y are equal. So maybe this is a constraint that you have to follow. Then there are ways that use the advantage, basically take advantage of the fact that the builder can have a state to add additional checks or put additional constraints. All right, let's summarize item 2. So what did we say about item 2? Again, item 2 is all about the builders. If you are faced with a lot of parameters that have to have some default values or can be initialized, right? So instead of making the desired object directly, the client with the builder interface calls a constructor or a static factory with all of the required parameters and gets a builder object, right? Then the client calls setter-like methods on the builder object to set each optional parameter of interest. Finally, the client calls a parameterless build method. So we said that the build method is part of the contract of the builder pattern, and normally it doesn't take any parameters and returns a type of the object that is supposed to be constructed to generate the object, which is typically immutable. That's why we use builders, right? The objects that we typically build with builders are immutable. Most likely the constructor of the object is inaccessible. You make the constructor of the desired object private or protected or package level access. Yeah, you just want to make sure the user, the end user of the API, is not able to access the constructor directly, which gives a strong hint or indication that if you cannot access the constructor, so you have to look for other ways. It could be factory method, factory classes, or builders, right? So the builder is typically a static inner class, as I mentioned, right? So you put it right inside the class itself of the class it builds, typically named builder. The builder pattern is a good choice when designing classes whose constructors or static factories would have more than a handful of parameters, especially if many of the parameters are optional. More importantly, builders have a state. So if you initialize a parameter through builder, it could affect the values of other builders, right? And the other thing, as I mentioned, my example was that inside the builder, you can have a static classes that limit the interface or limit the builder interface, the method calls that the user can have access. So the user can say new PointBuilder.Cartesian, and this returns a Cartesian, which is a static inner class inside the builder, PointBuilder, and that has access to only X and Y method calls, right? Especially if many of the parameters are optional. And again, Java doesn't allow default parameters for methods or keyword arguments, just like the way Python does. So we have to have alternative ways. And the best way that the people could come up with was this kind of builders or factory methods. Now, one thing that I'm not going to go deep into, I'm going to mention briefly, and you can always Google it and read more about it, is the recursive generics. So sometimes you want to bake the type of that, bake the type that the builder is working with inside the builder class itself, and that's via the generics. So you can have a builder that takes a type, right? So, and that's usually useful when you have a hierarchy of builders. Again, you might have a point class and have another builder for it, which is point builder. But then you might inherit from the point and create a Cartesian point. And now you want to create a Cartesian point builder for that. And that Cartesian point builder is going to inherit from the original point builder. So you have a hierarchy of builders in parallel with the hierarchy of the classes that you are implementing, right? And the way you want to keep the interface as fluent as possible is via recursive generics. So your builder is now has type parameter t, right? And this T is not going to be any type, it's going to be a type that extends the builder of T. So this is where the recursion comes from, right? And the reason is that now when you inherit and return the type T, because you want to create a fluent interface, and a fluent interface must return a reference to the builder object. So so you return in each method call, the return of the method call inside the builder hierarchy is T or any subtype of T. But then since you're extending or inheriting from the builder itself, you have access to other methods inside the builder. Now typically if you want to jump through the hierarchy classes in the builder, what you want to do, you want to define a separate method inside each builder implementation of the builder, which is called self. And self just returns this, but this basically depends on what kind of builder class it's currently inside, right? So I'm not going to deep into the recursive generics for the builder types, but just know that if you see a method called self inside the builder hierarchy, know that it's meant to create a fluent builder interface in a hierarchy of builder chains, right, which goes through the inheritance. So this was the end of item 2. I hope you enjoyed this. Please stay tuned and I'll see you in the next one.